Alright, and welcome back. Let's go ahead and take a look at actually using the simplex method. To use the simplex method, we will have to start with the initial tableau, and then from there we're going to want to pivot on the first pivot element. We will determine the column by the most negative entry from the bottom row, and then the row for the pivot element will be determined by comparing the constant and the entry in that row. So we're going to look at this in more detail, just doing a quick overview right here. Once you find the pivot element, then we have to pivot on that element. So remember, pivoting means that we make the pivot element into a 1 using row operations, and then we use that element to clear to make 0 every other element in the column. So we'll have to use row operations to do this. Once we've pivoted, essentially what has happened is we will now be at a corner point of the feasible region. So from the tableau, we'll be able to figure out what that corner point is and what the value of the objective function is at that corner point. If we need to, we'll pivot again until we find a maximum value of the objective function. So let's see how this actually applies to a problem. So we've been given the following problem, and we want to first set up the simplex tableau. So a couple things to note. We have 3 constraints, and so this means that we're going to have 3 slack variables. So I'm going to start by labeling the columns of my tableau. So I'm going to have an x1, x2, x3, because we have x1, x2, and x3 variables. Since we have 3 constraints, we're also going to have a slack 1, slack 2, and slack 3 variable, because we need to have 1 slack variable per constraint. After that, we have the z column, and then after the z column will be the constants. Okay, so those will go on the other side. So let's go ahead and fill in the information for the 3 constraints. So we have 5, 5, 10. Since I'm in the first equation, slack 1 should be 1, and then slack 2, slack 3, and z should be 0, and our constant is 1000. Now we're on the second equation, so we've done the first one, so now we're on the second inequality, which we're writing as an equation with the slack variable. So we will have 10, 8, 5. Now slack 1 only applies to the first constraint, so we have no slack 1, but we will have 1 slack 2 in order to make the second inequality an equation. And then we'll have 0 for slack 3 and for z, and our constant is 2000. So we've got the second one. And last but not least, we will have 10, 5, we have 0 x3, 0 slack 1, 0 slack 2, 1 slack 3, because we're on the third constraint, 0 for the z, and 500 for our constant. So we've got our constraints in. Now we just need to put the objective function on the bottom here. So let's go ahead and fill in the objective function. Now remember, when it comes to the objective function, we have to rewrite it a little bit first. And we do that by subtracting all the coefficients, all the variable terms and their coefficients to the same side as z. So we have z minus 100x1 minus 200x2 minus 50x3 will equal 0. So now we can go ahead and put our z function, our objective function, into the tableau. So the coefficient for x1 is negative 100, x2 is negative 200, x3 is negative 50. There are no slack variables, and we have 1 z, so our coefficient is positive 1. Last but not least, the constant on the other side is 0. Notice that on once the slack variables start, so if you look just at the slack variables over to z, you should have 1s on the diagonal and 0s everywhere else. So this should be like an identity matrix right here. That will always happen. Okay, so now this is where things get new. We have to find the pivot element. So our rule says that we find the most negative entry in the bottom row. So that would be the negative 200. This is the most negative entry. So that means that our pivot column is going to be column 1. So one of the entries in column 1 will be our pivot element. Now we have to determine the pivot row, and we do that by finding the ratio. So what we're going to do is we're going to take the constant for each row. So for example, row 1 has the constant 1000, and then we divide it by the entry that is in that row and the pivot column. So we would take 1000 divided by 5, and that would give us 200. For the second one, we will take 2000 divided by 8, and 2000 divided by 8 would be 250. And for the last row, we'll take 500 divided by 5, and that would give us 100. These ratios will determine the pivot row, and so the intersection of the column and the row will determine the pivot element. So let's see. If we need to pick the smallest non-negative ratio, so that would be 100. This is the smallest non-negative. And there are some things that you have to be careful of here, so make sure you read through the steps that were listed on the previous page. Sometimes you will pick a 0, okay, and sometimes you won't, and so there's a couple little things you want to read through. But anyway, okay, so we have the smallest non-negative. So that means that our pivot row then is going to be row 3. And so the intersection is 5. So the 5 is our pivot element. So we're going to pivot on the 5 and use row operations to make the 5 a 1 and to make every other entry in that column a 0. So we're going to pivot on the 5 and go from there. So let's see, the first thing that we're going to need to do, before I forget, this is important here. Let's go ahead and talk about what our current solution looks like. So from this simplex tableau, before we pivot anything, we do have a solution to our linear programming problem. We are at a corner point right now, but it's probably not going to be the corner point that we're looking for. So let's go ahead and talk about what the different parts of this tableau would be called. Let's see. Anytime you have a column, so for example the S3 column, where you have entirely zeros and one value that is 1, this is called a unit column. So in our case, S1, S2, S3, and Z, those would all be unit columns. The reason that a unit column is important is because you're going to be able to solve for that variable explicitly. And what we're going to do is anything that is not a unit column, okay, that's what we call a non-basic variable. So let's see. Our unit columns would be for the S1, S2, S3, and Z. We will say that S1, S2, S3, and Z are basic variables because they have a unit column. S1, S2, S3, and Z. The remaining variables will be non-basic. So this would be the X1, X2, and X3. In order to read the solution from the simplex tableau, we have to get what's called the basic solution. So you find your basic solution by letting the non-basic variables equal 0. So we're going to let the non-basic variables equal 0. So if we do that from our simplex tableau, this means that we have x1 equals 0, x2 equals 0, x3 equals 0. Now, if x1, x2, and x3 are all 0, then reading the first row of our tableau, we have 0 plus 0 plus 0 plus s1 equals 1,000. And so this tells us then that s1 would just equal 1,000. So similarly, if we read the second row, all the non-basic variables were 0. So we have 0 plus 0 plus 0 plus 0 plus 1, S2, is going to equal 2,000. So S2 will equal 2,000. And similarly, we'll get S3 equaling 500. And if we do the same thing on the bottom row, we can see that Z would equal 0. So this is basically the corner point that's at the origin, where everything intersects at the origin. And so our objective function is coming out to 0. Now by pivoting, and remember we're going to pivot on the 5, by pivoting we're going to move the tableau in a way so that it represents another corner point. And so by pivoting, we'll end up at a secondary corner point, and then from there we can test and see if we have a maximum or not. So let's go ahead and pivot. So I'm going to go ahead and list the row operations, but I'm not going to show them because otherwise the video would take an hour. Okay, so I'm going to go ahead and list the row operations. First, we would need to make the 5 into a 1. So we would do 1 over 5, row 3, into row 3. If you do that, then you should end up with the following tableau. We should have a 5, 10, 2, negative 100, 5, 8, 1, negative 200, 10, 5, 0, negative 50, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1/5, 0, 0, 0, 0, 1, and then we're at the constants, and this would be 1,000, 2,000, 100, and 0. So that would be our first row operation, and remember we are pivoting on, it was the row 3, column 2, and so now we need to use this 1 in order to clear the 5, the 8, and the negative 200. So the row operations would be negative 5, row 3, plus row 1 into row 1. We would do negative 8, row 3, plus row 2 into row 2. And I'm getting the coefficients right by the number that is currently in that entry, because we're trying to add up to be 0. And so finally in row 4, we would have 200, row 3, plus row 4. And this goes into row 4. So you should do the row operations by hand on your own, but I'm going to go ahead and show you what the matrix comes out to. So let's see, after we do the row operations, we end up with the following. So we have negative 5, negative 6, 2, 300, 0, 0, 1, 0, 10, 5, 0, negative 50, 1, 0, 0, 0, 0, 1, 0, 0, let's see, 0, negative 8 over 5, 1 over 5, and 40, 0, 0, 0, 1, and at the constants we have 500, 1200, 100, and 20,000. Okay, so here's our new tableau. This is now representing a different corner point, and so we can find a different basic solution from here. So let's go ahead and find our basic solution from this corner. In this corner, and I'll go ahead and relabel right here. So this was x1, x2, x3, slack 1, slack 2, slack 3, and z. Let's see. The unit columns are x2, s1, and s2. So x2, s1, and s2 should all be 0. Those would not be 0. These ones we can solve for on our own. The non-basic columns, so the non-unit columns, those are the ones we want to set to 0. So that would be x1, x3, and s3. Those should all be 0. Meaning that the unit columns, those are the ones that we can solve for. So x1 would then equal 100. And that's because x1 essentially what the third row says is 0 plus x1 plus 0 plus 0 plus 0 plus 0 plus 0 equals 100. And so x1 is going to equal 100. S1 would equal 500, and S2 would equal 1200. Okay. And finally, Z would equal 20,000. Now, notice this is a different point, right? So this is a different corner of our feasible region, and the Z value got bigger. And that's because our original solution was not the maximum. Okay? So now, how do we know if we're at a maximum or not? Well, that's determined by the bottom row. If there are any negative terms in the bottom row, then you're not at the maximum. So you have to pivot again. And so we have a negative term in the bottom row, so we're going to have to pivot. So our pivot column is going to be column 3. So we've got column 3 is our pivot column. And then we'll do exactly what we did before, where we find the ratios. So we'll do 500 divided by 10, that would be 50. We have 1200 divided by 5, which would be 240. And we'll have 100 divided by 0, which we can't do, so this means that this is not a pivot row. Pivot row. Okay. The smallest non-negative is 50, and so our pivot row is going to be row 1. So we need to pivot on the 10 that's in row 1. So now we're going to pivot again, and we'll pivot on the 10 in row 1. So you should go ahead and pause the video and do this on your own. You need to make the 10 into a 1 and then use that row to continue. I'll go ahead and continue after that point. So after pivoting, we end up with this tableau. Negative 1/2, negative 7 over 2, 2, and 275, 0, 0, 1, 0, 1, 0, 0, 0, 1/10, negative 1/2, 0, and 5, 0, 1, 0, 0. Let's see, negative 1 over 10, negative 11 over 10, 1 over 5, 35, 0, 0, 0, 1, and finally the constants 50, 950, 100, and 22,500. Whew! It's a lot of work. Here we go. So let's see, first column we have x1, x2, x3, s1, s2, s3, and z. Okay, so now let's go ahead and find our basic feasible solution, just like we did before. So our basic solution, the non-unit columns, those variables will all be 0. So we have x1 equals 0, s1 equals 0, and s3 equals 0. The basic variables we can go ahead and solve for. So x2 is going to equal 100. x3 would equal 50. And s2 is going to equal 950. And z is going to have a maximum at 22,500. So now we have a new solution. So this is a different corner point on our feasible region. So now if we look at the final row, notice that there are no negative terms in the last row. And so we know that this is our final tableau. And so we don't need to pivot anymore because this is our final tableau. So now the very last thing that we need to do is actually interpret our answer here. So what's our conclusion? We can say that z has a maximum value of 22,500 at the point, and remember the slack variables are not the variables we start with, right? x1, x2, and x3 are our variables. So at the point where x1 is 0, x2 is 100, and x3 is 50. And that would be our final answer. Okay. Whew, that was a long problem, but we got there in the end. The thing you want to be careful with is when you do your row operations, make sure that the arithmetic works out correctly, because if you make a little mistake at the beginning, then it can mess up the whole thing the whole way through. So be very careful, but we're just using row operations in a slightly different way. So this isn't entirely new from anything we've done before, just a different application of the same idea. All right, until next time.